So today we're going to talk about graphing quadratic functions from translational form. And here we have translational form is really called vertex form in most textbooks. But I want to show you both names. Now, if you read it says basically quadratics or parabolas are symmetric. Except for the vertex, you can find 1 point and you always get 2 points for the price of 1. So what that means is you find the vertex and you can find 1 point and use symmetry to graph that other point. So here's what translational form is, or vertex form. Y equals a times x minus h squared plus k. And the benefits, the biggest benefit is this: the vertex form tells you the vertex. It is hk. So notice how it's minus h, so it's going to be opposite the h and regular the k number. And A tells you if it opens up or down. For example, if A is positive, it opens up, and if A is negative, it opens down. So we'll start by graphing the first quadratic parent function, f of x equals x squared. So if we go ahead and just jot down, I always start using a few negatives, 0, and a few positives in my t-table, and plug them in. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So if I go ahead and plot those points, there they are, and I can sketch my parabola. Now the domain, that's our x values, it's our left to right. So if we look, this graph is traveling in the left direction forever and the same in the right direction. So it goes from negative infinity all the way through to a positive infinity, which means that the domain is all real numbers. Now my range, how low do I start? As I travel up from negative infinity, my graph starts here at 0. And it's got a bracket on 0 because it's inclusive. And then it goes up forever to infinity. Concavity tells you if the graph opens up or down. So you look at the leading coefficient here, and it's positive 1. So because the concavity is positive, the graph opens up. And you can also look. Obviously, our graph opens up. And our vertex, here it is, 0, 0. Now, this is a quick reminder about function notation. If you have a minus on the inside, it's to the right, 2, and a plus is to the left, 3. These are these transformations. And we've done this before, and these inside the parentheses are opposite the way we would think. Now, outside the parentheses are up-down shifts. So we have down 4, up 1. This is a reflection with the negative out in front over x-axis. And these coefficients in front are called stretches or shrinks. This is a stretch because the coefficient is greater than 1. So this is a vertical stretch by 2, and this is less than 1, so it's 1/2. So it's called a vertical shrink by 1/2. Okay? When you have multiple transformations, the order to perform them, the easiest way to remember that is just work from the inside to the outside. Or you can graph a function by step 1, plot the vertex. And then step 2, from vertex, you can go over 1, up 1, and then over 2, up 4. Because this is over 1, 1 squared is 1. Over 2, 2 squared is 4. So for example, if we look back at the picture, starting at the vertex, over 1, up 1 is a point. Over 2, up 4 is a point. So 1, 2, up 4. And the same in the other direction. Over 1, up 1. Over 2, up 4. And then use symmetry. Okay, so the next question says, given the function f of x equals a times x minus h squared plus k is the vertex form. If a is less than 0, h is greater than 0, and k is less than 0, which of the following are true? Okay, so let's look at what we have. A is less than 0. That means it opens down. When a is negative, it opens down. H is greater than 0, and k is less than 0. So let's think about which quadrant that would be in. So it's saying h, remember our vertex is hk, h is greater than 0. So that's a positive, and k is a negative. So if I go over in the positive direction to h, I'm in quadrant 1 or quadrant 4. I'm over here somewhere. And then if I'm k is negative, then from my positive x value, I go down. So I am somewhere, my vertex is somewhere down in quadrant 4. And we know that it opens down. So my vertex is not only down here, but the graph opens down, so it's going to look something like this. So let's look at our choices. The vertex is in quadrant 2. No. The vertex is in quadrant 4. Yes. Has no x-intercepts. So if it starts down here and it opens down, it's never going to cross. So that's true. Does it have no y-intercepts? That is never true of a parabola, because if this axis extends all the way down, eventually that will come over and cross. So that is never true. They always have a y-intercept. Okay, so now let's try graphing. Graph each of the following quadratic functions, identify the vertex, domain, and range. So, first thing I need to look at is where's my vertex? Well, it's hk, so this is supposed to say x minus h squared plus k. So it's the opposite sign here. So the opposite of plus 1 is minus 1, so that's h. And then k is the regular number, negative 8. So we're going to plot that, negative 1, 1, 2, 3, 4, 5, 6, 7, 8. So that's my vertex. I know the graph opens. I look at my leading coefficient, it opens up. So it's going to look something like this. My domain is all real numbers, because a parabola is always all real numbers. And because I know it opens up, my range starts here at negative 8 and goes to infinity. And a quick way to check some points, I always like to plug 0 in. So 0 plus 1 is 1. 1 squared is 1. Half times 1 is 1/2 times 8 is negative 7.5. So 0, negative 7.5 is a point. And I can use symmetry to then conclude if I go over 1 up a half, then I go over 1 up a half in this direction. And that's exactly what I can say, is over 1 up 1/2. And then over 2 up 1/2 times 2 is up 2. So this is at negative 6. And so then this also will be at negative 6 using symmetry. Okay, and the other thing we can show on this is there is symmetry along this line. There is a vertical line of symmetry. And I want you to add here axis of symmetry, because it's always a vertical line, so it's x equals, and it goes through that vertex, so it's always x equals the x value of the vertex. Okay, so for number 4, I want you, or this next graph, I want you to try graphing this on your own, and that's what I will check. Now, if we look down here, we have the graph of f of x is shown at the right. If the graph is moved left 4, shifted up 1, and stretched by a factor of 2, what's the new equation? Actually, I think I want to skip. We're going to skip this one. I'll do this one with you together. So let's go ahead and move on. I apologize. You can try it if you'd like. You can start with where the vertex is, move it left 1, shift it up 1, and you can at least find the vertex, and we'll kind of go from there. Okay, so let's look at these last two problems. If the function, it says let g of x equal -2 times f of x plus 4, and f of x is x plus 3 squared. Find the y-intercept. So we're going to find what of g of x. So g of x equals -2 times f of x. Well, f of x is x plus 3 squared. So I plugged that in, plus 4. Now if I want to find the y-intercept, then I need to let x be 0. That's how we find the y-intercept. So we have -2 times 0 plus 3 squared plus 4. What's 0 plus 3? Is 3. Squared is 9. Times -2 is -18. Plus 4 is -14. So our y-intercept is 0, -14. Okay. Last question is write the equation of the quadratic function with a vertex at 0, 1 and f of -2 equals 13. So the first thing we need to do is write what point this is. Typically, we say f of x equals y, and we've covered this before on how to get points. So x must be -2 and y must be 13. So our vertex form is y equals a times x minus h squared plus k. And now let's plug in what we know. I know this is x, this is y, this is h, this is k. So let's plug all 4 of those values in, and the only variable we'll have left is a. So y is 13 equals a times x is -2 minus h is 0 squared plus k is 1. So we have 13 equals a times -2 minus 0 is -2 squared is 4 plus 1. Subtract 1 from both sides, and I have 12 equals 4a. And so divide both sides by 4, and a equals 3. So now I can rewrite my equation as f of x equals, I'm rewriting f of x equals, a is 3, and I have x minus h squared plus k is 1. And I can simplify this because x minus 0 is just x squared plus 1. So that is our function. So even given a vertex and a point, we can write an equation. So make sure that you take the time to go over this problem. There will be a problem on the test where you're given this information and you have to find a. So this is your chance to study that. Go ahead and make sure you have done this graph that we talked about, and then also attempt this problem right here. But this must be done for full credit. Hope you have a great day.